Anyway, so you guys, I'm assuming everyone was able to get home safe or get someplace safe for now. I know you guys unfortunately had to vacate the premises. At least most of you did. Uh, so, um, with that being in mind, and I'm sure for those who did have to leave on short notice, I know some people were they had contacted me. It's like, I've got a problem and I'm told I gotta leave and I'm trying to get a flight back home, um, and I can't find one, or I can't find one till Saturday or something, and everything's all crazy. Um, I believe there's an assignment that was due like today, uh, and so I want to push that back to Thursday just to give a little bit extra room because of situations and craziness and whatnot. Um, Also, just as an FYI, today's lesson is going to be a little bit short, um, and that's okay. Uh, it's kind of really an extension onto what we talked about last week, um, but uh, the excuse me, but uh, so if you look at the chapter in the book, it's not real big. It's kind of, like I said, an extension, but it's an important part that you need to know about because it's going to deal with multidimensional arrays. Before we get into that, though, I just want to kind of open it up for questions to see if anyone has a question about uh, the arrays and what's going on with them. If you have any questions, now's a good time to ask it because you can't really do today's lesson if you don't understand what we did last class or last week in dealing with arrays. And I know arrays are a little bit different than how we've done other types of data types in both Python and C, or if you have other programming experience somewhere else, it's a little bit different in some ways. So just real quick, if you have any questions, you can put it in a chat window, or you can unmute your mic and ask. I want to make sure we get a good solid basis there. Okay. I'm not seeing anything in the chat window. I'm not hearing anyone unmute their mic and say anything. Let's go ahead and get started. Share my screen. Okay, so today we're going to talk about two-dimensional arrays. And a two-dimensional array, you sometimes will hear them referred to as a matrix. If you've done anything with matrices in math, this is kind of very familiar to you. Um, what you'll find is how we move actually from two-dimensional arrays to three-dimensional arrays and four-dimensional arrays, etc., is very, very similar. So there's not going to be a lot of confusion as far as that goes. Basically, the general form is you're going to have your data type, your array name or your matrix name if you prefer, and then two sets of square brackets with the associated sizes inside of those square brackets. That's kind of the default way. So if you kind of look at the example I have here down below, it's int matrix 10, 5. So we have 10 rows and 5 columns. In order to access an element, you will need to specify uh, both indices. So you have two indices now, a row indice and a column indice. You need to be able to specify both of those. You can also, just like with a regular array, you can go in and declare your variables and have C++ try to determine what size the matrix is. So if you look here, this is actually, it kind of looks like a array of arrays. That's kind of how it's set up. We have our curly braces here, and then we have a set of curly braces inside of them, individual elements. So this is our first row, and these are our associated columns. Now, with that, this is something that is, it's not unique to C++, but it is an important thing you want to keep in mind, is that all of our columns, all of our individual rows that have those columns, those arrays need to be the same size. C++ is not going to allow you to have an array of differing size arrays. So if my first row has an array of 5 elements, my second, third, fourth, etc. rows need to have 5 elements inside of them. Okay? If it's 10, then they all need to have 10. If you try to make something of a different size, C++ is not going to like that. Because if you remember going back to what we talked about with an array, in C++, it tries to find one continuous place to put all of that data and memory. Now, when a computer program is running, and this is kind of the same way a hard drive works, the computer just puts variables in different memory spots. Okay, so it's got to work around. You might have enough free memory, but it's got to find a contiguous space that's free of that size. With a matrix or a multidimensional array, you've got to have that much more space because you're dealing with not just 10 elements, you're dealing with 10 times 5, 50 elements. So now you're way out here. Instead of being here, you got to find this bigger group. Okay, and you could, 10 by 5 is a small matrix. You could have 100 by 50. Okay, so now you got to find 50,000 elements worth of space. And that didn't take very long to get that big, believe it or not. If I had a matrix of assignments and grades for every assignment and stuff, and then I had a list of students. Okay, so I have a student, so that's my rows. My columns are all my individual grades that I have for you. That very quickly gets very large, believe it or not. It doesn't take long to have a class of 20 people with 20 or 30 assignments. So C++ has to find that contiguous space. And it does some internal things to make that a little bit easier. You don't have to know how that works. That's on the programming compiling side, but it does work like that. Okay. Like I said, if you want to assign values, we're going to close that so we don't see all the spam that comes to me. If you want to assign a value or you want to read a value, you must give it both indexes into your multidimensional array. Okay, if your multidimensional array has 3 sets, so you have rows, columns, and then like depth or something like that. If you're thinking of a 3-dimensional array, then you have to give all 3 indices. If you have a 4-dimensional array, much harder to visualize, but you could have it. You have to give all 4 indices. So however many elements in an array you have to give that much an indice for every index into it. Okay. So the way we're going to generally process this is through nested loops. So let's take a look at what that's going to look like real quick. Come over here. Other assignments, just don't care about that. Okay, so I'm just going to create, just for simplicity's sake, a matrix of integers. I'm going to say int matrix, and I'm going to come back and specify my size in just a minute. Okay, so I'm going to define some global constants. Excuse me. Oops. It'd be helpful if I specified data type. And then I'm going to specify a size of my columns, which will also be 10. And now I can put in here rows and calls. Okay. And that's just a nice, simple way to define my matrix. If I want to go in and assign some random values to this matrix, okay, I'm going to use a for loop. int I equals 0, I less than my rows, and then I'm going to use a nested for loop. So this is going to move me down through each row, but remember I also have to go across each column. Oops. And now I can say something like matrix I j equals rand minus 3200. Okay. If I want to print this out, oops, I have a small problem. None of you guys caught that. I specified I in my inner loop. It's supposed to be j. Okay, fix that. Now we don't have an issue. Okay, so this is just going to go through and assign some random values to my array. If I want to change how many columns and rows, I can come up here and do this in my constant, which makes it easy. I'm going to come in here and I'm going to just print out this information so we can see it printed out. It's going to be the same basic thing. So I'm just going to copy and paste this. Okay. The difference is instead of assigning a value, we're going to take that part out. We want to do a C out. Okay. This is going to let me print out my matrix indice. Now I don't have an indel here because that's going to move me to a new line. And I want to see all of my columns on the same row. But I do need to separate them out with some sort of spacing elements. So I'm going to use a tab character. And a tab character, I just use \t. That is going to give me my tab character. And then when I get through moving through my columns, my J, now I'm going to come here, see out in line. And the reason why is this is just going to go through and now move me down to a new line so I can see my new row. If I run this, you're going to see here's my 10 columns and here's my 10 rows. So this was I was 0, J was 0, I was 0, J was 1, I was 0, J was 2, etc. down the line. Then I came down, and when I got through my inner for loop, so when I got through this inner for loop, and then hit my end line and move me down here. With my end line, now I start back with J equals 0. So I was now doing matrix C 1, 0. This would be 1, 1, 1, 2, 1, 3, etc. I get all the way down to the end, 2, 0, 2, 1, 2, 2, 2, 3, etc. And we just kind of keep going through that process. So whenever I deal with a multi-dimensional array, 9 times out of 10, I'm going to use nested for loops to work through that process. Because whether I'm trying to find average for my row or I'm trying to find some other element, this lets me kind of go through that process. And as I mentioned, this is real easy to change. So if I want to have 15 rows but only 7 columns, I just change my constant. This information stays the same. And now I have a matrix with random values that are printed out. As you can see here, more rows, less columns. It was real easy to make those changes. So use those constant values is a real help. Okay. Now, what would happen if I said, but I want to take this particular value set, for example, this for loop, and what I really need to do is I want to put that in a function. I want to isolate that logically so I can just say initialize matrix. Okay, so that's not too difficult to do. We do have a method. There are two things that are kind of important about this, however. Okay, so here's an example where I had a function called sum. You can use a function for anything. Remember, function names and what they're doing doesn't really matter in this case. We have here a const because we're not wanting to change it. Remember that when we passed arrays to our functions. I have my array, and notice I have two square brackets, but I have to specify my column size. Okay, I have to specify my column size. Very important to note. Reason why is that in C++, it needs to know when am I moving to my new row. I know that based upon how many columns I have. So I'm going to show you how we're going to do this in just a second. And then I also, once again, I'm passing my row size. That's just being passing as a element into my array. But my column size has to be defined inside of my function prototype and function header. So this does become a little bit more of a challenge to work with because I have to know how big my array is going to be when I go to compile my code. Okay, so that's kind of a weird thing in a lot of cases, but it's okay. It works out because we don't use this very often. You use arrays all the time. You don't use matrices very often. So it doesn't wind up being as big a problem as you would think. So let's do the example here where we're going to go in and do an initialization for our matrix here. So I'm just going to come in here, void init. I may or may not want to use init. I'm just going to throw this out as a just an example real quick. Reason why I like init is because it is short. It's easy to write. It's hard to misspell. Less letters, easier to spell correctly, right? On the other hand, init real quickly can look like int. And I might not want to have a function name or a variable name that looks too similar to a keyword. Okay, so if I look at that, I go, oh, did I read that correctly? Maybe I want to use initialize. Maybe I want to be very clear with my name and say initialize matrix. That's okay too. It's just kind of up to you as far as how that goes. So I'm going to choose initialize matrix real quick because that gives me something that's a little bit bigger and easier to see. Now I'm going to need to have my matrix that's going to be updated. So this is going to be int array. I don't know how many rows. I do need to specify how many columns. So I'm going to pass in my global variable. And then I'm going to specify my row size and rows. Notice that this parameter is lowercase. This is uppercase, so it's not going to get the same values. Notice that here I'm using that constant value. So if this comes in here and changes for whatever reason, it's okay. We have it's going to be updated every place that it's used. This is why we like using those constant global variable or global values. It's not a variable. It's not going to change. It's constant. But because it is constant, we can use it and keep everything in sync. I don't have to go and find the 5, 6, 2 dozen places I'm using it. I change it one time, one place, and it works for me. So that's a really nice feature. Okay, let's come down here real quick. Let's write out this function. Okay, I'm going to cut this from my main program. And what I'm going to just do real quick, change that name. Call still stays the same because that's a global variable, but this is being passed in as a value, so I'm going to use that parameter just for simplicity's sake. Come in here, we call initialize matrix, pass in matrix, and oops, not calls, rows. Just like that. Okay. Because this is an array, we are going to pass by reference, so we don't have to worry about returning anything. We don't have to do anything like that. We're not using the const keyword because we want to change the value of the array. And now if I just run this, you'll see that it runs and exits out just as it should. You're noticing that it's going to create a different set of random values. So if I come in here and I run this again, I should get a different set of values. I may or may not because I'm not running the sran command. Remember, sran is going to help us randomize it and create a more random number. But I do see my values as I would expect here. Okay. Excuse me. So that's just kind of how that works. If I want to go and create another function for the printing out, that would also work the exact same way. And once again, because all my values are coming in, this is obviously my constant. This value is coming from my constant that I pass in here at initialize my matrix. If I come over here and make a change, I can change this too. I'm only changing one spot. It's going and figuring out all the information for me. So that makes it really nice and simple as far as that goes. And like I said, that's working now whether we're using a function or we are using, arrays where we're doing all inside of our main. Those global constants are just, they're doing a lot of that heavy lifting for us. Makes our lives a lot easier as a developer. And that's the key thing we want to do is we want to make our lives as developers easier. Um, we don't want to have to stress and worry about all those different combinations of things that can happen and keeping track of something and I got 31 of them but I missed the 32nd one of where that value was set, and that's way too much work. Okay. So use those global constants whenever you get a chance to. I use them a ton when we're doing arrays for, as you see, and those type of methods and reasons. So just kind of keep that in mind. Okay. If I wanted to have, excuse me, a third value, it would literally look something like this. Depth. You go, oh, now my matrix isn't working correctly. It says, oh, I got an error here. That's because it doesn't match up with our function there. Okay. You go, well, wait a second, is this actually right? Yeah, that's actually the way it would work. You have to specify in a multi-dimensional array. The only one that you don't specify is this inside one, the rows. My columns, my depth, my whatever my fourth and fifth and sixth dimensions will be, I always have to specify them in size. The good news is you don't really run into three-dimensional matrices very often. That's kind of a rare thing unless you're doing some sort of mathematical type of operation. So if you're doing work dealing with some sort of math computation, you're going to run into that. But in reality, most math simulation type software and such, that's now being done in something like R or Python. So the chances of seeing this is pretty slim. Not that you'll never see it, just pretty slim. If I were to go in and make additional changes so I can see that, what I need to do is I would need to add an additional inner loop or int k equals 0, k is less than depth, a plus plus, oops, I, j, and k, like that. That's literally the change you would make. So working with adding additional levels of complexity to your matrix is really not that difficult in some ways. In other ways, it's you just got to kind of keep track of which um, set of dimensions am I in. But that's how you work with it. You can just add additional multi-dimensional arrays. Um, it's pretty rare. You don't run into it very often, like I said. But just so you know how to do it, that's something that's not in the book, um, but something that you can do. All right. Any question? Let me just double check, make sure there's nothing else I need to cover on that. Nope, that was it. Okay. Any questions that you have about multi-dimensional arrays or arrays in general? Let me make sure I bring up my chat window. I don't always see that. Okay. I'm not seeing any chat. Okay, so what I want to do is I'm going to remember we do have that time limitation of I think it's like 40 minutes, so we're right around the 10 minutes left mark for this. So what I'm going to do is I'm going to exit out of this if it's okay with you all. And then I'm going to restart this in about 5 or 6 minutes. It takes a few minutes for me to download this file and convert it so I can be able to turn around and upload it to YouTube for you guys and anyone who misses this lesson. And then I would, if you guys have any questions with the homework, I would like to just take that time to let you guys. I'll be online. You guys can ask questions on the homework. I know I've gotten a couple of emails about it. I know, and that's not to be unexpected. Working with arrays is a little bit different. Uh, it's not hard, it's just different, and it requires kind of shifting that mind gear. And so once you do that, it goes, oh, okay, and you just start working with it. It's not difficult. But I'll stick around if anyone needs or to have any questions about that. If you're good, if you're ready to submit or whatever, feel free to do that. If you haven't had a chance to work on it, please make sure that's done. Like I said, I want to give you uh, time to work on. I know you guys might have lost some time this weekend and whatnot. So, like I said, if you guys have any questions, I will be back in about 5 minutes, and we will have a chance to go over that homework and assist you in any ways that you need there. Okay? I will see. Oh,
Just to be clear, if we don't have any questions, class is done.
yes. So if you're done with the assignment, you don't have any questions. The rest of the time is I just get back to you. You end up having about an extra 30 minutes or so free. Um, so this is just kind of the equivalent of in class time to work on something and have me here to answer whatever you need. So, but if you don't need it, you are free to go. All right. Any other last minutes before we stop and then resume in about 5 minutes? All right. Well, I will see you there if you need it. If not, have a great rest of your day.